But this so I left in question 6, so this would be a second video, but I almost where I left off. So for this one, which is section 5.6, so it would be, so when you cancel this, you have a 1 at the top, so it has a 7 here. There's nothing here, but you have a 1, so you put a 1 right there, and then plus 21 over 7 would give you 3, and then this one cancels out and that one becomes a 1, so you're left with that one. Remember, you divided this, so this became a 3 and that one a 1. So at the bottom you're left with x, and then the top you're left with 3 only. Everything else went away. This one became a 1, that one became x to the 1. Okay, plus 49 divided by 7 would just be 7, and then the x squared stays at the bottom. So that would be the answer for this one. Now let's do this one. So this is a long division. So you're gonna put this on the side like that. And then a3 plus a2 plus 2a plus 6. Okay, so this one has 2 terms, so you're gonna start your quotient here under this term. So you know the bottom term, the bottom variable tells you how many you need, how many a to the how many do you need. So you need a squared, right? Because you always look at this bottom one. And then you want to make this look like that. It has a 1, that one has a 1. So basically this is it. We don't need a number here because that one's a 1 and that one's a 1. So now you distribute like that. A squared times a will give you a cube minus positive, so minus 2a squared. Okay, so remember we're subtracting, so this one becomes negative and this one becomes a positive. So obviously this one cancels out or it becomes 0. So plus plus, so there's a 1 here. 1 plus 2 gives you 3 a squared, and then you bring this one down. So plus 2a. That the symbol of this term, remember, it tells you the symbol of this next term on the quotient, which is positive. Number of a's at the bottom tells you how many you need on top, so you need 1a. Now we need to make this one look like that too, so we need to, not that too, sorry. We need to make that like this one. So we have the a, right? A times a gives you that a squared, but we need the 3. So we're going to multiply this by 3. So 3 times 1 gives you 3. A times a gives you a squared. Then minus 2 times 3 is 6, and then the a. So we're doing subtraction, so this becomes a minus, that becomes a positive again. So that cancels out, so 2 plus 6 gives you 8a, and then you bring down the 6, so plus 6. This again symbol here for this first term tells you what the symbol here, so positive. There's no 8 here, so we're not gonna have 8 here. So, but we do have an 8. We need to make whatever number we have here look like that. So what can we multiply 1 times to get 8? Well, obviously that would be 8. So 8 times 1 would be 8, and then the a. 8 times 2, negative 16. So this is minus again because we're subtracting, and this one becomes positive. So this cancels out, and this one gives you 22. So this is a remainder. So now let's, the final answer is a quotient plus a remainder. So a squared plus 3a plus 8 plus 22 over the divisor. Sorry. A minus 2. And that's the answer for 7. So 8, use synthetic division. So for this one, we're going to use synthetic division. So we need the C. And the C is always the opposite sign of this. So negative 2. So we're going to put negative 2 here as a C. And then draw a line here. And here we're going to need the coefficients of this. But we need to see if it's complete. It's missing parts. 4, 2, so it's missing the x cubed. And it's missing the x here. So I'm going to put 3x fourth plus 0x cubed, and then minus 2x squared plus 0x plus 10. So now we have a descending order polynomial 4, 3, 2, 1, and then the number. So that's complete. So those coefficients, including those zeros, you're going to put here. So 3, and then I'm going to put it red so that you guys remember those we included in there, 0 and 10. And we're going to bring down the first number. And then we're going to multiply like that and put it here. So we're multiplying, and we're going to place it here. So 2 times 2, negative 2 times 3 gives you negative 6. Negative 6. Is it this one? Yeah. So, and then vertically we're going to add. So 0 times plus negative 6 gives you negative 6. Now we do the same pattern. Negative 2 times 6 gives you positive 12. And then you add, and that gives you positive 10. And then negative 2 times 10 gives you negative 20. And then you add again. So that gives you negative 20. And then negative 2 times negative 20 gives you positive 40. And then you add. That gives you 50. So this part is the remainder as if you were doing long division. So now we just need to, these are the coefficients of the quotient of the new polynomial that we got from this division. And you always start with this first coefficient, and the letter that follows it, that accompanies it, it's always one less than the one we started with. So you're gonna have x to the third power, one less than the original. And then you do the following one, 6x squared plus 10x minus 20 plus 50 over the divisor, which is this. So x plus 2. And that's, I'm just double checking I did it right. Yeah, got it right. So that would be the answer for that one. Okay, solve the following equation. So this is from section 6.6. So here, each of the factors we're gonna equal to 0, and then we're gonna solve for x, and those are the solutions for this. 6.6 right here. So okay, so let's split this into two different equations. The 4, when you, if it doesn't have a letter, that one you don't really need it. It goes away because you can have 4 equals 0. It does. That's a false statement, so you don't use that one. So 5x plus 1 equals 0, and then you do this one. X plus 3 equals 0. Now you solve for each So minus 1, minus 1. So that one goes away. So you have 5x equals negative 1. Then you divide by 5. So that goes away. So you end up with x equals negative 1/5. This is the first solution. Now we need to get the other one, minus 3. So x equals negative 3. So those are the two solutions for that one. Yeah, those are the solutions. Now this one, the same thing, section 6.6 is just it's different. So that one you need to solve. So remember, for this type of questions, when you're solving equations like that, they have to equal 0. So one side needs to be 0. So we're gonna bring the 16 to this side. That goes away. So you have, put a red 0 here, and then I'm gonna put this like this, plus 16. Okay, now distribute this x, because we want a polynomial here. So x squared, and in this case, is going to be a quadratic one. Minus 10x plus 16 equals the 0. So we're trying to solve like we did here, but here we need to find the factors first in order to solve. So x. So remember, you can do the x if you want, or if you don't need it, that's fine. So I'm factoring this one. So 1 times 16, so the 16 goes here, and then the negative 10 goes here. So two factors that equal this, it would be 2 and 8. So 2 times 8 gives you 16, but they don't give you negative 10, so that means both of them need to be negative. Negative 2 times negative 8 gives you positive 16. When you add them, they give you that negative 10. And then the leading coefficient, you put it underneath. So that tells you there's 1x, it's right here, minus 2. And there's 1x, minus 8. Okay, so now from here, you split them like that. 0, and then x minus 8 equals 0. And then you solve plus 2 plus 2, so x equals 2, plus 8 plus 8, so x equals 8. So this goes away. So these are the solutions for this one, for that 10. Okay, 11. The area of a rectangle is 80 square meters. The length of it's one more than 3 times the width. So you have a rectangle, they're telling you the area is 80 square meters, so that's why I have it here, 80 square meters, the area. And then the length, which is the longer side, is 1 more, so 1 more means plus 1. Then 3 times the width. 3 times the width, we don't know what the width is either, so I'm going to name the width x. And the length is going to be 3x plus 1. So x means the width. And the length is 3 times the x plus 1. Okay, so, and this is from section 6.7, which is this one. So how do we find the solutions of these? We're going to remember the area, because it wants us to find the dimensions of the rectangle. So they want us to find x, the width, and the length. If you find x, that means you find width. You substitute here, that means you can find the length. So the area is just length times width for a rectangle. They're giving us the area, so you're going to put 80 equals the length is this whole thing. And then the width is just the x. So we need to do the same thing we did over here. We need to bring everything to one side and then 0 to the other. This one I'm gonna distribute the x first. So 80 equals 3x times 1, so 3x squared, and then plus x. Sorry, I should have put it green. So 3x squared, right? 3x times x gives me 3, and then x times x is x squared. And then from here, you bring everything to one side. So this thing cancels. So now you have a 0 here. So 3x squared plus x minus 80. Okay, what follows after that? We can solve like this, so you're gonna find the factors of this thing. So let's make a note here. Let's find the factors. So this is those more complicated ones. So you're gonna do a times c 3 times 80, negative 80, 3 times 8, 24, so negative 240, and then they need to equal 1. Let me see if it's, so I think so let me see, 3x 80, yes, okay. So here I think we're gonna have to multiply. Let me find the factors really quick. So two numbers that multiply to that and add to this. It's gonna be this, yeah. So it's 16 times 15, and this is negative, so that means one of it has to be negative because they add to a positive. So if we make that a negative, that wouldn't add to a positive, so this one has to be the negative. So 16 times negative 15 gives you that, negative 240. 16 plus negative 15 gives you the positive one. So at below it, you need to pull the leading coefficient of this. So this one. So let me write it here. 3x squared plus x minus 80. So that leading coefficient goes here. Like that. And then you need to see if they can be simplified. That one can't. And that one does simplify. So negative 15 divided by 3 is negative 5. Over, you still put the 1 on the bottom. That one can't. So now these are the factors. So it tells you the x's. So 3x, and that one's 1x. 3x plus 16, and that one's minus 5. Okay, now once you have that, it's just a matter of so we're gonna split them like that, and then we're gonna equal 0. So 3x plus 16 equals to 0. X minus 5 equals to 0. So plus 5. So x equals 5. Those are not the answer, but and then minus 16 minus 16. So 3x equals negative 16 divided by 3. So x equals negative 16 over 3. Now, since we're dealing with dimensions can't be negative, so we're going to scratch this one. That's the one that we can use, a positive one. So that means the width, which is x, and x is equal to what? 5 meters. So the width is 5 meters, and the length, it's 3x plus 1, which is 3 times 5 plus 1. So 3 times 5 is 15 plus 1. So the length gives you 16 meters. And those are the dimensions of the rectangle, of this rectangle. Okay, so let me do this too. So this is from section 7.2. So we're now simplifying rational expressions. We're dividing them in this case. Perform indicative operations, so we divide into rational expressions. So this is a type where you have to figure out if anything can be factored, and I know for sure that one can be. So this one, I'm going to do the KCF from the beginning, so that's going to become a multiplication, so do the KCF also. So keep this one, change that one, and that one's going to flip. And then this one is, I'm going to factor it. So two numbers that multiply to that and add to positive 1, it's 7 and 6, right? 7 times 6 gives you 42, but negative 42, and then they need to add to a positive 1. So that means this has to be the positive, and that one has to be the negative, because they add to a positive. So the positive number is a bit bigger. And we have it set up now. So after that, just combine everything, x plus 7, x minus 6, x minus 3 squared. So this is the numerator. This is x minus 3 and x plus 7. Okay, so you know that goes away. And I'm going to expand this one so that you guys see what happens here. Put it here. So x minus 6, x minus 3, x minus 3 over x minus 3. So what happens here? Well, this one cancels. And you're left with this x minus 6 and x minus 3. That's the answer. And that's for section 7.2. I'm going to do this and then I'll create another video. So this is performed, so now we're subtracting. Even if when you're subtracting, you need to have the same common denominators in order to combine it. Now you're gonna have to find either the LCD or just the LCD. Or you can do it. I was thinking of this one, or you can do that complex rational fractions. This one, it's the same, so we have a common denominator, so it makes things really easy. So just copy this 9x plus 7 minus, and then I'm gonna put this in parentheses. Don't forget, that's very important, because that negative will affect these two terms, not just the 3x but also the 4. If you don't do parentheses, you might get confused or get the wrong answer. So 9x plus 7 minus 3x minus 4 over 6x squared. So from here we're going to combine like terms. So 9x minus 3x gives you 6x. 7 minus 4 gives you positive 3 over 6x squared. Okay, from here I notice that we can GCF a 3 from this one. So the 3, it's outside. So 6 divided by 3 would give you 2x. 3 divided by 3 would give you positive 1. So these two can be simplified. So that becomes a 1 and that one becomes a 2. 3 over 6 is 1/2. So you're going to have 2x plus 1 over 2x squared, and that's all you can do for this one. I'm going to stop the video and create another one. you guys.